Today we're going to do problem 24, 91. 2 plus 4 is 6 plus 1 is 7. 9 minus 7 is 2. Times 2 is 4. Minus 9 is negative 5. Plus 1 is negative 4. I don't know where I'm going with this. Divide players into teams of equal size. Okay, so you're given ignore that. You're given a positive integer array skill of even length n, where skill I denotes the skill of the ith player. All right, so we got some players with skills. Divide the players into n divided by 2 teams of size 2, such that the total skill of each team is equal. The chemistry of a team is equal to the product of the skills of the players on that team. Okay, so if I have skill 5 and my team member has skill 3, together we have skill 15, or chemistry 15. Return the sum of the chemistry of all teams, or return -1 if there's no way to divide the players into teams such that the total skill of each team is equal. Okay, so So we have example. Let's just go ahead and get into the example. I'm thinking about how we're going to solve this. I haven't really looked at this problem yet. So I have some ideas. This is a very mathy kind of problem, right? Because I'm trying to think about like what would have to be the size of the team I divide players into. Is there like a more optimal pairing, right? But I don't know. The way that this is given too, right? It doesn't make it seem like it's possible for there to be a more optimal pairing. And now that I'm thinking about it, it makes sense why there's not like return the best chemistry, right? Like it says return the sum of the chemistry as if there's just one chemistry, right? That's kind of what this is implying. It's not like return the sum of the best chemistry matching you could get, right? It's just saying there is a chemistry that you could get. There's only one, return what it is. Okay. So skill equals 3, 2, 5, 1, 3, 4. Okay. And then we divide the players into the following teams. So we have a team with 1 and 5. We have a team with 3 and 3. And we have a final team with 2 and 4. And our chemistry score is just 2 times 4 plus 5 times 1 plus 3 times 3. So we have 8 plus 9, which is 17, plus 5, which is 22. So we have a total chemistry score of 22, and that's what we return. For this, we just have one team that we can create, right? So it's 3 times 4, 12. And then for this one, you'll notice there's no way to divide the players into teams such that the total skill of each team is equal. Okay, so for this problem, I guess the first thing I'm noticing is, well, you have to split n players into teams into n divided by 2 teams, okay? And each of those teams have to have the same size, right? So if you have players A, B, C, D, E, and F, if you split them into teams of the same size, so you're going to have the first team, we'll call that X1, X11, X12, X21, X22, X31, X32, right? So these are your 3 teams. Now, if all of these teams are the same size, right? So that means that the size of X11 plus X12 equals X21 plus X22, right? Because all these teams are the same size, right? So this is the same size, this is the same size, and this is the same size. Max, stop. Sorry, my dog is, I think he's on drugs or something. I'm not sure. But if all these teams are the same size, right? So X11 is the same size, this is the same size, this is the same size. Right, so that means X11 plus 12, X21 equals this, right? These things are the same size, and I can make the same argument about the other 3 things. And, well, the total size of this whole system, right, is the sum of the whole system, right? So x11 plus x12 plus x21 plus x22 plus x31 plus x32. This is the sum of the whole system, right? I'm just summing every single node, right? Because this is a node, 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 this is a node. And these things are all the same size, right? So this is like 3 times x31 plus x32. So I'm just trying to find a way to gain some intuition about what I'm trying to get to, because there's these relationship between things. So from these relationships, can we determine something? So if these things are all the same size, right? Whatever that size is, right? So the size of each of these systems, right, that we sum into, right? For here, it's 5, right? Or 6, right? Because all of these nodes together have size 6, like 2 and 4 are 6, 3 and 3 is 6, 5 plus 1 is 6, right? So these things together are 6. So we know that, well, all of these things are the same size. So this is the same size, this is the same size, this is the same size. So this is equal 3 times S, where S is the size of the system that we're trying to find. But this is also equal to the sum of the whole system. So let's ignore that. All right, so this is the sum of the skill array. All right, so I'm just replacing this. So this whole thing here is the sum of skill, but it also, and then one of these things alone is the size of a group, right? That's the group size. And in total equals 3S. So the size of one group is 1/3 of the sum of skill in this example. And how did we know what that was? Well, we said it was 3 because we had 3 groups. Right? There's 3 groups. So there was... Sorry, I'm trying to think about how this works. So this is sum of skill. There's 3 groups. So the size of one group is equal to the sum of all the people divided by the number of groups there's going to be. So the number of groups is n divided by 2, right? That's how many groups there are. So the size of one group is equal to 2 times the sum of skill divided by n divided by 2. Sorry, it's been a while since I've done simple math, I guess. Divided by n. So that's the size of one group. So that's the equation that I just pulled out of my butt. So let's see if this actually makes sense. So the sum of skill is... And n is the length of the system, right? So the sum of skill is 5 plus 5 is 10 plus 5 is 15, 18. So this is 18. 18 times 2, 20 times 2 is 40, minus 4, 36. 36. And then what's the length of n? 6. Divided by 6 equals 6. And the size of a group is 6, right? 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6. So what I'm basically trying to get at here, this whole process, right? What I'm trying to basically say is, like, how do we know what the size of each group is, right? Because we're going to given this skill array, and we need to figure out, like, okay, we're going to be splitting these players into teams. So what is the size of each team, right? We need to find, like, if I have a player, what would be the size of the other player that player needs to be with? And it turns out, from doing this math, what I basically said is, well, we know that each size of the group, there's n groups, right? So there's group 1 plus group 2 plus ... n divided by 2 groups plus group n over 2, right? And each group I is going to equal a unique pair of people, xi1 plus xi2, right? Because those two people are together to make the size of the group, because that's the size of the group, right? So the size of group 1, the size of group 2, the size of this. right? So that means that each group I is replaced by a unique xi and xi2. So this then equals x11 plus x12 plus x21 plus x22 plus dot 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 plus xn over 2 1 plus xn over 2 2, right? But all of this together is the sum of the array, the sum of the sum of skill, right? All this together. But all of these are also the same size, right? Because g of 1 is the same size as g is 2, which is the same size as g of n over 2. So we have n over 2 of something we'll call s, which is the size of g, equals the sum of skill. So that means the size of each group then is just 2 times the sum of skill divided by 2. So now we know the size of each system by kind of following this mathematical process, right? So if I'm given any node, for example, 3. So if I'm given a person 3, and I'm going to say, okay, who is 3 supposed to be matched with? Well, 3 needs to be matched with the other side of their size, right? Because this system here, right, has size 6. So S equals 6. So since S equals 6, 3 needs to be matched with a 3. If I'm given a 2, right, and I'm given this node 2, and it's like, okay, who do I match 2 with? Well, since I know S equals 6, the other part of that is, well, S equals 6 minus 6, so then we have 6 minus 2 equals 4. So 2 needs to be matched with a 4. So since I know the value of size, I can determine who someone else needs to be matched with in any case. All right, so what's the problem in this example? Well, what's the size of each set going to be? Well, the sum of skill equals 3, 5, 6, 7. Sorry, not looking so good. Remember, we said our size is 2 times the sum of skill divided by n, and n is 4. So 14 divided by 2, and so this doesn't even have a full size, right? Because sum of skill, so we have 14 divided by 4. That's not an integer, right? You need to have an integer size. I can't match 1 with 4.2 or something like that. So that indicates that there's no way to even divide these players up because there's no even full size that I can divide them into. And then how do we know that there's no like better chemistry? Well, your chemistry is just the multiplication of each group, right? But each person only has one other person that they can be matched with, right? Like in this example, 2 can only be matched with a 4. So it's only going to contribute 8 in terms of chemistry, right? Because it's 2 times 4. So there's only one way that this system can be built, right? There's only one way in which I can match 2 and 4, right? Since 2 has to be matched with 4, it only can contribute 8 to the total chemistry of the system. It can't contribute more. I can't match 2 with somebody else to get a higher chemistry score, or match 2 with somebody else to get a lower chemistry score, because 2 can only be matched with 4 because all the groups have to be the same size, which is a constraint of this S variable. So how do we solve this problem then? Well, what we can do is we can keep account. We first find, I guess the first thing we should do is find the value of S. And we'll do that by running the algorithm, right? S equals 2 times the sum of skill divided by n. And then we will take account for everything that we've seen. So we'll keep account of like all the values we have so we know who we can match with, right? Like we'll take a ledger like, okay, we have a 4, we have 1 4, we have 2 3s, we have 2 5s, we have 1 this, we have 1 that. That way we can figure out like how we can match people together, right? Because what we want to do is when we're presented with a person, right? When we're presented with a person with skill 3, we want to see if we have a count of someone else that they can match with. So we're going to use a hash table to find a match to account for everyone that we have. Somehow there's some weird part of this I'm trying to think about. And then we're going to look at each person. So we'll look at each person and ensure that they have an associated match. And if they do, I'm not going to write the rest. If they do have an associated match, because you can probably barely read my writing as it is. If they do have an associated match, we'll add that into our total chemistry score. And if they don't have an associated match, we'll return we'll return -1 because we can't find the system. So first, let's find the size of our match. So S is going to equal, well, we just did the algorithm, right? So 2 times the sum of skill divided by N. And what's N? N is the length of skill, right? That's the number of nodes. So that's the size of each system. Let's create this hash table. And it'll be a counter of counting how many of each thing that we have. So we'll default dict, the default value is 0. We'll look at each value in skill. So each skill in skill. Okay, so now I'm wondering if there's like a two-sum way of doing this. Like, so we look at each person. So let's have a gratitude score. So I'm thinking of a better way of doing this. So if a gratitude equals 0, so if we find a person and their associated person isn't in the, so we're kind of cutting out a step here, right? So what we'll do instead, this just hit me. It's like a two-sum approach. It's like just my pure genius. Just kidding. There's probably people in competition who solve this problem in like 4 seconds. We're just like, oh yes, of course. The Pascal's triple-double theorem on January 4th, 1465 of alluring mathematical properties. Done. So that's not me. So I'm not that smart. But so for this example, right, we know that skill equals 6. And imagine we had this empty hash table. And then when we look at each skill, so I'll write down the skills of each person again. So 3, 2, 5, 1, 3, 4. When I look at 3, so I'll first look at 3 and I'll say, okay, 3, do you have a match? Well, to have a match, that would mean that 6 minus 3 needs to be in the hash table. If not, then I'll add 3 to the hash table with value 1. So I'll say, okay, I don't have anybody to match you with 3 yet, so I'll just add you to my ledger, and later if I find someone to match you with, I'll remove you. Okay, I do the same with 2. For 2 to be matched, there needs to be a 4 that I've seen. I don't have a 4 yet, so I'll add 2 to the system and say, look, 2, I got nobody to match you with, so I'm just going to add you to my ledger, and if I find somebody to match with you later, I'll save that information. Then I look at 5. In order for 5 to have a match, it would need 1 to be in the ledger. 1 is not in the ledger. Only 3 and 2 are. So I'm like, okay, sorry, 5, for you as well. I'm sorry. Like, you're just another person where you don't have anybody to match with yet. So I'm going to have to add you to this system. Then I look at 1, and I say, okay, 1, you can match with a 5. And oh, look, it turns out that I have a 5 in the system to match you with. So you guys can get matched together. So I'll just, instead of erasing it from the ledger, I'll just set it to 0, which is effectively erasing it. And then I won't add 1 because I found a match for 1. And then my gratitude score will equal 5, right? Because that equals 1 times 5. And before it was 0. And then I have a 3 and I say, oh, look, 3, there's a 3 inside of my ledger already I can match you with. So I'm going to just remove him from the system. And I'm going to match you guys together. And then I'm going to add that into this solution, which is 3 times 3, which equals 9. So now we have 14 total in the system. And then I'll look at this final 4 and I'll say, okay, 4, who do you need to match with? Oh, you match with a 2. And look, I have a 2 who's been waiting to be matched. So I'll match you guys together, and that will add into the system 4 times 2, which equals 8. So plus that in, that equals 22, which is the whole shebang. So we'll just run through. So if we see somebody and we don't have somebody to match with, we'll save them in our hash table, hoping that later we'll find somebody to match them with. Okay, so we'll look at each person. We'll say, okay, well, if S minus this person, so that's who this person would match with, is in the hash table, well, there would be S minus SK. If it's greater than 0, then gratitude would plus equal what? S times, because S is going to get SK is going to get matched with S minus SK. And then that we have one less of that person, right? Because it's possible that you have multiple of the same people in a system. So we minus 1 there. Otherwise, we add SK to the system. So this is a very two-sum kind of approach. Right. Very much seems like I'm doing a two-sum problem here. And then what does it mean if you don't have a solution? So if you get to the end, right, and you haven't matched, I'm trying to think of the best way of doing this without, so return gratitude if what? If all of the keys in HT, if all their values are 0, so there's nobody left. I'm trying to think of the cleanest way of doing this. I don't want to do it like that. We'll just do this. We'll say matched equals 0. Every time we match someone, it's kind of ugly. We'll say matched equals plus equals 1. So we'll return gratitude if matched equals n divided by 2. Because that means that we matched everybody, right? Because every time we match somebody, we create a new group of size 2. And there's n divided by 2 matches, right? So match should be n divided by 2. Otherwise, if we haven't found a match for everybody, we return -1. Local variable gratitude. Okay, so misspelling. It's a common thread with me. N is not defined because it's called length of skill. Yeah, that's fine. I can make it an integer because making something an integer, it won't work. You won't be able to find the groups if it is an integer. Boom! Boom! Okay, so what's the runtime of this solution? So this is a constant operation, constant operation, constant operation, constant operation. We look at each person and skill, and then we ask a question in the hash table. Now, technically, this could be in the worst case n, but we just consider hash tables constant operations. So we look at each person. We look at each instance in the hash table. So this is a constant operation. Whoa. I don't even know you could do that. This is a constant operation, constant operation, constant operation, constant operation. So everything inside of here is constant. So we just need to look at each skill and do a constant operation for each skill. So that's an end time run time. And then this is also constant. So what's the runtime of this? Well, the runtime is just O of n, right? Because n is the length of skill. And then what's the space? Well, the space is also O of n, right? Because I could add each person. It's n over 2, but it's scale of n, right? Because I could add each person's pair to the hash table. And the way that this works is I end up adding I add every single skill, right? Every single person into the hash table. So that's O of n space. All right. And then let's just go ahead and make all the haters mad and make this solution super short for no reason. So to do that, 0, 0. You can leave now if you don't want to watch me make this ridiculously hard to understand and short, but it does help to make it short to get people's attention on the comment section. So this could all be on one line. So gratitude equals gratitude plus this. H of t equals -1. And the last thing equals matched +1. Oh, and then now since this is one line, we can move this back here. And now it's a 4-line solution. For some reason that got lost in translation. I don't know. 4-line solution. All right, guys. Have a good day. Bang, bang, bang. Can't see me.